So take a look at these three linear equations here. They are all linear equations. And I want to answer this question. Is each of these lines, are they horizontal, are they vertical, or are they, let's call diagonal for not horizontal or vertical? Okay, remember the kind of the key quick technique we have for making this identification is we look at the variables. If an equation has two variables, then it's diagonal. If an equation only has an x, it's vertical. If it only has a y, it's horizontal. Okay, so we can see pretty quickly here. The first one only has an x, so this one is vertical. The second one has an x and a y, that's diagonal. Now this middle one, yeah, it's a little complicated. There's some simplifying we can do, but you simplify this and it's just y equals 5. So this one is horizontal. And now this last one is the cautionary tale, right? At first glance, it looks like there are two variables there. There are x's and y's. But remember, this is always the case in math, algebra in particular. You always want to simplify before you start making any kind of determinations, right? So if I were to simplify this, I could combine some like terms. I could subtract 3x from both sides. And if I do, this one goes away, and this one goes away, and all that's left is y equals 4. Now we're down to just one variable. So this one is, in fact, a horizontal line. All right, so let's say I'm trying to find an equation now. So let's say I want to find the equation of the line through these 2 points. Okay, well, there's nothing wrong with just going to the methods that we've seen before. Find the slope, put the numbers into the point slope equation, and see what happens, right? And simplify what you get. But look, it pays to just have this little quick filter on these kinds of problems. If we graph these points, I'm going to go over -3, up 5. I'm going to go over 4, up 5. And you can see pretty quickly, this is, in fact, a horizontal line, right? So if I'm doing these, I don't even go that far. Again, like I said, I've got this quick check filter in my head. As soon as I see that the y coordinates are the same, that is really where this question ends for me. At that point, I can immediately say, this is a horizontal line, and I know that the equation of a horizontal line is just y equals that common number, and I'm done. Right now, if you're taking this on a test, for example, I always expect my students to show their work, to justify their answers, and there wasn't a whole lot of work going on there. But you can still just explain that quick reasoning that took place. Say the two y coordinates are the same, therefore this is a horizontal line, so the equation must be y equals 5. And that would be fine for me in terms of showing your work, so to speak. All right, so here we've got the same idea, but we're going in the opposite direction. And remember, let me graph these real quick. I'm going to go over -3, up 2, over -3, up 7. We sketch a quick graph, and you see, give or take my sketchy art skills, that is in fact a vertical line. Now this is the one where you have to be careful. You really can't go to the point slope equation here because the slope of this line does not exist. And I know I kind of fudged it a little bit in the last lecture, but I want to repeat again. That was really purely just for illustration purposes. You really should never, ever, ever try to treat the slope of a vertical line as if it's a number. There's just too many roadblocks and landmines and unpleasant things you could trip over trying to treat it that way. This is a case where you really need to make that identification. You really need to say, okay, look, the two x coordinates are the same. Because the x coordinates are the same, this is a vertical line, and the equation of a vertical line always looks like x equals that common number, and you're done.